I'm gonna hold this camera while we explain this problem. Okay, so we have the pen problem. You're given that there were 5 faulty pens and 7 working pens. And you should recognize that this is a tree diagram problem because you have 2 situations. First, the boy picks a pen, and then the girl picks the pen. So we can set that up. You have a tree part that represents the boy picking the pen. I've put him first. So, what are the chances that it was faulty? It was 5 out of 12. What is the chances that it worked? It was 7 out of 12. Now, no matter what, he keeps his pen, so he's not replacing it. So now you're done with this. We move on to the second trial, which is the girl picking the pen. The boy did not put his back, so now you only have 11. Well, if he chose a faulty pen, then he has a faulty pen in his hand. So how many are left? There are 4 out of the 11. There are still 7 that work. And we have a total of 11, which adds up to 100% in this part. Same thing down here. If he picked the working pen, there are only 6 more working pens left. If he chose a working pen and she picked a faulty pen, well, there's still 5 faulty pens in there that she could pick from, so it's 5 out of 11. And again, we can double check this and notice that these 2 numbers add up to 11 out of 11 or 100%. So we checked this part, which adds up to 12 out of 12. We checked this branch, which adds up to 11 out of 11. And we checked this branch, which adds up to 100%, 11 out of 11. The last part of setting up your tree diagram is to come up with your summary table. So what are possible branches? You can see here's one route, here's a second route, here's a third route, and here's the 4th route. Okay, so the first route is faulty and then faulty. 5 out of 12 times 4 out of 11 gives us 15.2%. All the way down until we have this final branch, work, work. The probability that it works and then it works, 7 out of 12 times 6 out of 11, which equals 31.8%. And if we double check these, they add up to 100%, so we're good to go. Our first question asks, what is the probability that the boy picks a faulty pen and then the girl picks a faulty pen as well? Well, we can see that right from our summary table. Boy picks faulty and girl picks faulty. They both pick faulty, and that's 15.2%, so that's how we got our answer to A. B asks, what is the probability that there's at least 1 faulty pen? Well, I can find those situations. Here's at least 1, here's at least 1, and here's at least 1. So in other words, 15.2 plus 26.5 plus 26.5, and I get a final answer of 68.2%. That is the probability that there is at least 1 faulty. Finally, the most challenging problem is the conditional probability problem, a given statement. Given that there is exactly 1 faulty pen, exactly 1, what's the probability that it was a girl who took the faulty pen? So I set up my conditional probability. I'm reading. What is the probability that the girl took the faulty pen, given that there is exactly 1 faulty pen taken? So my second step is to write down, I can find my conditional probability formula in the formula packet. I'm going to write that down and label this as A, label this as B. Thirdly, I'm going to find the probability of B because I need that. The probability of exactly 1 faulty pen, again, coming over here. Here's exactly 1. Here's exactly 1. This one has 0 and that one has 2. So 26.5 plus 26.5 gives us the probability of a faulty pen is 53%. I can substitute that into my formula already. Lastly, I need to find this part. What is the probability that it was a girl who took the faulty pen and there was exactly 1? So I set that up. Probability that the girl picked the faulty pen and there was exactly 1 faulty pen. Again, looking at all our things. Here's exactly 1, but it was a boy who took it. Here's the one where there is exactly 1, and the girl took it. So that's 26.5%. I found that part as well. So I found this part, it's 26.5. I found this part, it's 53. If I divide those 2 things, I put in my calculator, 26.5 divided by 53, I will get 0.5, 50%, or 1/2. Any of those forms work. The end. Thanks to Bella for the editing and moving around.
Oh, yeah.
Okay, bye.